This first question is a variation on the standard Venn diagram question. The sense in which this variation is that instead of giving you all the information you need and then asking you to compute something, we have a partial amount of information and are asked to find the maximum possible probability. Or likewise, we might be asked to find a minimum probability. All right, so what is the probability that we're being asked about? We want to know. All right, so we have some customers who have auto insurance. I'm going to label customers with auto insurance. I'm going to label those people as being A. And we have some customers with homeowners insurance. I'm going to label these people as H. All right, so what do we want? We want maximum possible probability that somebody with auto insurance. So we're conditioning on having auto insurance. We want the probability we do not have homeowners insurance. So we want a probability of H complement given A. And by the definition of conditional probability, it's the probability of H complement and A divided by the probability of A. The probability of A, we're told, is 0.75. So what we want to do is we want to maximize the numerator. All right, now, this looks in many ways like a Venn diagram question. So there are two ways that we could think about maximizing the numerator. One is to do it intuitively and figure out what the answer is. The other, which is the way I'm going to do it, is to draw a Venn diagram. Or actually, I'm going to draw two Venn diagrams that are opposite possible extremes. And because they're going to be the opposite extremes, one of them must be the maximum. All right, so what are my Venn diagrams going to be? Well, what I'm going to do is I'm going to consider two possibilities. One where I have the maximum overlap between the two, and one where I'm going to have the minimum overlap. All right, so how can I have the maximum overlap? Well, the way I'm going to have maximum overlap is if we have our 75% that are people with auto insurance, there are fewer people with homeowners insurance than with auto insurance. So the maximum overlap we could have would be to have the homeowners insurance be purely inside the auto insurance. There's 40% of people with homeowners insurance. So this leaves 35% of people without homeowners, within HC and A. So without homeowners insurance, but with auto insurance. All right, now our minimum overlap possibility. Well, what's our minimum overlap possibility? Again, we draw our set A. Here I'm going to draw it in such a way that there's not going to be a possibility of having a complement to A and H combined, because the probability of A and the probability of H add up to over 100%. If they add up to less than 100%, the minimum overlap picture would be that they don't overlap at all. All right, so what's the maximum overlap? All right, so A takes up 75%, so that leaves 25% outside of it. So the minimum overlap is, I push A all the way to the left as I can. I push H as far to the right as I can. H is a total of 40%. I have 25% that's not in A, so that leaves 15% that is in my overlap. And so what's left in A, because A adds up to 70%, is 60%. All right, so the maximum possible probability from these two extreme pictures of H complement and A is 60%. All right, so my final answer is going to be 60% divided by the probability of A, which is 75%. And so I get D.